Assalamualaikum warahmatullahi wabarakatuh. Okay, so today we continue 4.4 Understanding Gas Law. These are our learning outcomes. So number 1, explain gas pressure, temperature of the gas and volume of the gas, okay, in terms of the behavior of gas molecule. And then determine the relationship between pressure and volume and temperature, then pressure and temperature. Okay, so do you realize that we have three physical quantity here, which is pressure of the gas, volume of the gas, temperature of the gas. So you remember PVT. PVT. Alright, so we determine the relationship between all of this, okay, for a fixed amount of gas. So it means that the gas has same mass. And then the third one is to explain absolute zero and absolute temperature. Okay, so later we look at that. And then finally, solve problem involving pressure of the gas, temperature of the gas, and volume of the gas. Okay, this is for a fixed mass of gas. Okay, so but before that, we need to look at what is PVT for the gas. Okay, so this explanation will be based on kinetic theory. Okay, so when we say volume of the gas, so the volume of the gas actually equal to the volume of the container. Okay, because gas occupied space in the container. So we say that the volume of the gas will be equal to the volume of the container. Okay, so why we say like that? Because when there is a gas in a container, so the molecule of the gas will be moving freely in random motion. Okay, so it means that the gas will fill up the whole space in the container. Okay, so the volume of the gas will depends on the volume of the container. Alright, now temperature of the gas. So the molecule of the gas will move randomly. Okay, so they will have average kinetic energy. So this kinetic energy will be proportional to the temperature. Okay, so it means that the temperature of the gas represent the average kinetic energy of the gas. Okay, so the greater the kinetic energy of the gas, so the greater the temperature of the gas. Then pressure of the gas. So when the gas are in a container or not, if outside the container also, gas actually moving randomly. Okay, so if let's say we place the gas in a container, it will still moving randomly, and at every time the molecule collide with the wall of the container, it will bounce back. Okay, so every time it collide with the wall of the container, the molecule will bounce back. So it means that there is change in the speed, in the velocity. So it means that there will be change in momentum. When there is change in momentum, so it means that force will be exerted to the wall of the container. So the total force per unit area is actually equal to the pressure of the gas. So this is actually formula for the pressure of the pressure, P equals to F over A. So the force exerted by the gas molecule divided by the area it collide with the wall of the container. So that is the pressure of the gas. Okay, so remember, for the gas law, we will focus on three physical quantity, which is the P, V, T, pressure, volume, and temperature. So we need to say pressure of the gas, volume of the gas, temperature of the gas. Okay, so there are three gas law. So we have Boyles law, and we have Charles law, and also pressure law. So there are three gas law. So we have Boyle, pressure, and Charles law. And then when we look at Boyle's law, okay, so these two will be the manipulated variable and also the responding variable here. Okay, so let's say the volume is the manipulated variable, the responding variable will be pressure of the gas, and the temperature of the gas will be constant. Okay, and then if let's say we are talking about pressure law, for pressure law, the manipulated variable will be the temperature, responding will be pressure, and then the opposite of this here, volume will be the constant variable. As for the Charles law, okay, so remember this, temperature will be the manipulated variable, responding will be volume, and then the one that opposite here is the constant variable. Alright, and then for all the gas law, we fix the mass of the gas. So this is very important for your paper 3. Let's say you are asked to plan experiment to investigate the relationship between volume of the gas and temperature of the gas. Okay, so the manipulated variable will be the temperature, horizontal axis of the graph, and then the vertical axis will be the volume of the gas. And for Charles' law, there are two fixed variable, two constant variable, which is the mass of the gas and pressure. So you better remember this triangle. Okay, remember this triangle. Alright, so I will suggest you to make notes by in table form like this. If you make notes in table form like this, very easy for you to see the difference between Boyles law, Charles law, and also pressure law. Okay, you write the definition, what is the formula involved, uh, draw the apparatus arrangement, what would be the graph, okay, of the experiment, what is your manipulated, responding, and also fixed variable. Okay, this is your homework. You better make for your own good. Alright, so now we look at specific. What is Boyle's law? Now you know that Boyle's law from the triangle just now. Okay, Boyle's law investigate the relationship between volume of the gas and pressure of the gas when the mass and the temperature of the gas is constant. Okay, so Boyle's law states that for a fixed mass of gas, the volume of the gas is inversely proportional to its pressure when the temperature is kept constant. Okay, do you see the word PVT? P pressure, V volume, temperature, and then don't forget mass. Okay, so when you write the definition, make sure you have this variable, this physical quantity. Okay, so Boyle's law said that for a fixed mass of gas, the volume of the gas, okay, the volume of the gas is inversely proportional to the pressure of the gas when the temperature is kept constant. So we can write proportional sign like this. V is proportional to 1 over P, means that inversely proportional to P, or P, pressure of the gas, is inversely proportional to volume of the gas. And if let's say we change this into equation, we will get this equation. Okay, P times V is a constant. So from here, we can write this. This is what you need to memorize. P1 V1 equal P2 V2 equal P3 V3 equal P4 V4, and so on. Okay, so where this will be the initial, 1 is for the initial situation, and then 2 will be for the final condition. So means that P1, pressure of the gas, initial, and then V1, volume of the gas, initial. Okay, and then P2 will be the final pressure, V2 will be the final volume. Alright, when you want to solve Boyle's law question using this formula, remember the volume of the gas left and right side this equation must be same unit. You can use cubic meter, you can use cubic centimeter, but make sure left and right side have same unit so they can cancel it later on. Same goes to the pressure. So pressure of the gas, left and right side of this equation must have same unit. Okay, it can be in Pascal. If P1 is Pascal, P2 also in Pascal. If P1 is in kilopascal, make sure your P2 also in kilopascal. Okay, if let's say not the same, if they give you prefix, so make sure you change the prefix lah. Okay. Alright, so this is the definition for pressure law. again, you need to look at this, P, V, and T. Okay, so pressure law said that for a fixed mass of gas, the pressure of the gas is directly proportional to the, this is an important word, absolute temperature. Okay, when the volume is kept constant. So from here, we know that P directly proportional to the absolute temperature. So that's why we can have this equation. P directly proportional to absolute temperature. So from here, we can get an equation. Okay, like that. So P1 over T1 equal P2 over T2. Alright, so what is absolute temperature? Okay, later on I explain what is the absolute temperature. And then for the Charles law, okay, again, this is just introduction for you to clear about the gas law. Okay, so Charles law, again, you look at PVT. P, where is P? Here, pressure. V, volume. T, temperature. And then don't forget the mass. So when you want to define all the gas law, make sure you have P, V, T plus the mass of the gas in your definition. As for Charles' law, it said that for a fixed mass of gas, the volume of the gas is directly proportional to the absolute temperature when the pressure of the gas is kept constant. So here, the volume of the gas directly proportional to the temperature, and you can write equation like this. Okay, so P1 over T1 equal P2 over T2. Okay. Okay, so this is the apparatus set up to determine the relationship between pressure and volume of a fixed mass of gas at a constant temperature. Okay, so we use pump and then connected by using a tube to a Bourdon gauge. Okay, and then the Bourdon gauge is connected to capillary tube that has oil inside it, and then there will be trapped air in the tube. Alright, so the air trap here, okay, will be compressed if you exert force on the pump. Okay, so what happens if you exert force on the pump? Right, so the volume of the gas here will become smaller, and then you will see the meter, the pointer of the Bourdon gauge will increase. Okay, so it means that the smaller the volume of the gas, so the bigger the pressure of the gas. So it means that they are inversely proportional. Alright, so if let's say you reduce the pressure, so the volume of the gas will be increased. Alright, so we know that now the pressure of the gas is inversely proportional to the volume of the gas. If let's say we plot graph of P against 1 over V, okay, you will get a directly proportional graph. Okay. Alright, now if let's say you plot graph of V against 1 over P, you will get directly proportional. Okay, just like this just now. Alright, so P you can interchange it because for Boyles law, these two can be interchanged. Okay, you will get the same graph. Let's say V against P. Also, you will get an inversely proportional. Okay, like that. But if let's say you plot graph of PV, you calculate P times V against V, okay, you will see that all the time it has the same value. Same goes to PV against P, because from here we know that P times V is a constant. No matter what is the value of your V, if you plot graph of P against times V, the value will be the same. Like this, P times V, the value is the same no matter what is the volume of the gas. Here will be the PV, P times V will be a constant no matter what is the value of P. Alright, we do some exercise. You see here. So the air in the cylinder of a hand pump has an initial volume of 800 cubic centimeter, and the pressure of the gas is 102 kilopascal. Okay, Then the air is then slowly compressed by the pump to a volume of 160 cubic centimeter. So now the volume reduced. Okay, what is the pressure of the compressed air in the pump? Okay, by looking at this, you know that the pressure will be increases. Because why? The volume is getting smaller. So the answer should be more than this value. Okay, so when the temperature of the gas is not mentioned here, we can understand that the temperature of the gas is a constant. So this is Boyles Law question. Now, what is given? So we try to write in using symbol, just like this. So P1, 102 kilopascal. Oh, this one should be capital P, Pascal. So 102 kilopascal. V1 is 800 here, 800 cubic centimeter. And then V2 given is 160 cubic centimeter. They ask you what is P2. So use this formula. Okay, and then substitute the value, you will get that. Okay, do you realize that when you use unit, the unit must be the same so that you can cancel the unit. So now the answer is 510 kilopascal. Can see, right? So the pressure of the gas is bigger when the gas is compressed to a smaller volume. Bigger, the pressure of the gas now is 510 kilopascal, which is bigger than 102 kilopascal initially. Alright, so Boyle's law. Okay, this is what we already understand just now. Okay, so V is directly proportional to 1 over P, or P is directly proportional to 1 over V. Okay, I said directly proportional to 1 over P, which means V is inversely proportional to P, P is inversely proportional to V. So if we change it into equation, we get like that. Okay, so this diagram hopefully can make you understand. So when the pressure of the gas, when the volume of the gas is more, so the collision between the molecule and the wall of the container will be less. But when you compress, okay, so the kinetic energy of the gas is the same because the temperature is not changed. But since the distance is getting smaller, so the collision between the gas and the wall of the container will be more. If let's say more collision between the molecule of the gas and the container, so the force will be more, hence the pressure will be more. Okay, because the area is getting smaller. Alright, so now we must remember volume of the gas is inversely proportional to the pressure. Memorize this formula. Alright, now look at this question. So the air in foot pump has an initial volume of 2800, and then the pressure is 100 kilopascal. And then the outlet of pump is closed and the piston is pushed inward until the volume increases. Is it increases? Oh, sorry, decreases. Decreases to 700 cubic centimeter. What is the pressure of the gas? Okay, so the volume now smaller. Okay, what is the pressure? The pressure should be more lah. Okay, use that formula. P1, V1, P2, V2. Okay, so P1 100, P2 V1 is 2800, correct, right? P1 is 100 kilopascal, V1 is 2800, and then this is your V2, 700. There, just calculate. Okay, and then the unit, just follow the unit of this P1, which is in kilopascal. Okay, now look at pressure law. Okay, so this is already discussed just now. Pressure law states that for a fixed mass of gas, the pressure of the gas is directly proportional to the absolute temperature when the volume is kept constant. Okay, P directly proportional to T. If we want to write the equation, we will get like this. Memorize, huh? So this is the apparatus setup. Okay, so we'll be using Bourdon gauge again because Bourdon gauge is used to measure the pressure of the gas. Okay, since we want to know the relationship between pressure of the gas and the temperature of the gas, okay, so we need to have Bourdon gauge to measure pressure, and then of course thermometer to measure temperature. Okay, so the gas is actually is in this um, flask, round bottom flask. The gas is inside the round bottom flask, and then this is sealed. All right. Then the round bottom flask is placed in the water bath. Okay, because we want the gas to be heat up at a constant temperature. Okay, heat up means that all the time the temperature of the gas is uniform. All right, so um, we measure the temperature of the gas. The thermometer now is outside, but it's actually it measure the temperature of the water, represent temperature of the gas. Okay, so we measure the temperature of the gas, and then we measure the pressure of the gas by using Bourdon gauge. Okay, so you need to tabulate your data in table. Okay, so temperature and the pressure of the gas. Then after that, you plot your graph. You will get like this. Okay, so pressure, uh, because the temperature of the water will be in between 0 to 100 degrees Celsius. More than 100 degrees Celsius, the water already becomes steam. So it means that you can get data, any data in between this reading, 0 to 100. Okay, now if let's say less than 0, the